So you're good with polynomials, right? Let's see if we can graph them. We're gonna try and graph the opposite of polynomials. All right, what kind of a function is this f of x? You see that 2 minus x? No? How would you go about graphing 2 minus x? It is a linear function, no?
Mm-hmm.
So what was the difficulty there? It's just a straight line. They've given you the y-intercept. They've given you the slope. What's the y-intercept?
2,
Yeah. What's the slope?
1.
It's -1. So that means for every 1 unit you go down, you want to go 1 unit to the right. And there you go. These are my 2 points. And I can combine them. And then that's going to give me my sketch, right?
Mm-hmm.
So this is the linear function. What is a domain? Now, domain, what does it mean? It means possible x values. Is there any restrictions on this straight line in terms of what x values it can take? Usually restrictions will be, well, it's a straight line, right? Polynomials, they have no restrictions on their domain, okay? This is a linear function, which is a polynomial. Polynomial means like something like x squared, x cubed, anything x to the power of a number. And this number has to be a whole number and cannot be negative. So there's no restrictions when it comes to the domain of a polynomial. So we can say the domain, there's 2 ways to do this. You can either do this in the set notation, or you can do this in the interval notation. I'm going to show you both. The domain. Domain means the possible x values it can take. And the set notation will be from -infinity to +infinity. It can be anything, okay?
Mm-hmm.
In terms of the interval notation, it's going to be x is an element of all real numbers. So that's how you can do it in both ways. XCR just means x can be anything on the real number line, which is from -infinity to infinity. Range. Range means the possible x values. Is there any restrictions on the range for this function? Range means the y value, okay? Can y be 0? It is passing through the x-axis. That means y can definitely be 0, yeah?
Mm-hmm.
So I can look at this. Is there any like break in the graph? That's what kind of gives you the range. This line is gonna go all the way up here, and then this one's gonna extend all the way down here, yeah?
Mm-hmm.
All the way down here you have -infinity. All the way up there you have +infinity on the y-axis. Same thing here. You have -infinity all the way here, and then -infinity all the way here. As you can see, there's no restrictions or either x or y. It can be anything from -infinity on the y to +infinity on the y. Same thing as the x. A linear function, any odd degree polynomial, like a polynomial is again odd degree means x to the 1, x to the 3. These guys have no restrictions on their domain, and they also don't have a restriction on their range. So the range itself is also going to be -infinity to +infinity. In terms of the interval notation, it's going to be y can be any real number. Okay, does that make sense or no?
Yes. Mm-hmm.
Because yeah, it doesn't. Like if it was a quadratic though, quadratic means x squared. For the domain, it's a polynomial. There's no restrictions. But in terms of the y value, the minimum is a 0, right? For a quadratic, the parent function, the range
Mm-hmm.
will be y has to be bigger than or equal to 0. Quadratic, there's a restriction because there's a minimum value. But for any odd degree polynomial such as x cubed, it looks like this. There's no restrictions on neither the x nor the y. The next one, positive, negative intervals. So positive interval means where the y value is positive, okay? It's positive up until this point. What's the x value here?
0.
The y value
Oh,
is 0. What's the x
2.
value? 2. So it's positive, okay? It's positive. When, again, intervals, all of these guys, you're gonna say it in terms of the x values. So the function is positive all the way from negative infinity to 2, okay? Is 2 inclusive or no?
It's inclusive.
No, it's not, because at exactly 2, the y value is 0. Okay, is 0 a positive number or is it a negative number? It's neither. Or both, I guess, depending on how you want to look at it, but it's neither.
Okay.
What about the negative interval? Where is the function negative? It's negative to the right of this, right? The y values are negative to the right of this point. So what will be the interval? It'll be from 2, yeah,
Mm-hmm.
all the way to what? Infinity. And this is how it works, okay? We're looking at the y values, but we're gonna say it in terms of the x values. Here, look at this. Let's say we have some weird looking graph like this. Let's say this value is 5, yeah? The x value there is 5. It's above the x-axis up until this point. So the positive interval where the function is positive is when the x value is less than 5. You see, when the x value is 4, 3, 2, 1, 0, the function is positive, yeah?
Mm-hmm.
Where is it negative in terms of the x values? It's negative to the right of 5, you see here? When x is 6,
Uh-huh.
7, 8, 9, 10. So what do we say here?
When it's more than 5.
Yeah, when it's more than 5. Same idea here. Positive interval for us is when x is less than 2, because it's above the x-axis up until that point. And negative interval for us is when x is greater than 2. Okay, this is just a set notation equivalent. Does that make sense? Here, try this. Where is the function positive and where is it negative? For this one. You have everything you need. You see this point? -3 on the x. No? Well, as you can see, it's positive here, right? Do you agree?
Mm-hmm.
So what's the x value? What's the cutoff point? It's -3, right? So it's positive when x is greater than -3. As you move to the right of -3, the function's positive. And it's negative when x is less than -3. Yeah?
Uh-huh.
Does that make sense?
Yes.
You just look at the graph basically and you see what's positive, what's negative, and intervals are gonna be in terms of x. This graph, is it going up or down?
Down.
Down, right? So look at this. The next question is increasing, decreasing intervals. This function is always going to decrease, right? It's going down
Mm-hmm.
all the way through. It's never gonna increase. So in terms of that, it's gonna decrease from negative infinity to positive infinity. For any value, for any x value, it's always decreasing. Cool?
Mm-hmm.
Okay, we're gonna do the same thing, but now we're gonna do it for a different function. I just wanna hammer this idea home because it's not that tricky, but let's say your graph looks like this, okay? Let's say this point is -2. Let's say this point is +2. And your vertex is at, again, this doesn't really make sense, but it's okay for our purposes. -1, -3 is our vertex, okay? What type of a graph is this? Which function does it represent? Is it linear?
No.
So what is it? X to the power of what? It's a quadratic, right? It's a parabola
Uh-huh.
that's opening upwards. So what's that x to the power of?
2.
2, right? That's x squared. Is x squared a polynomial?
Yes.
Yes, it is. Are there any restrictions on the domain for a polynomial?
No.
No. So in terms, what's the domain of this function? What's the possible x values it can take?
-infinity to infinity.
Yeah. So that would be the domain. If you want it the other way, you can write x is an element of all real numbers. What about the range? Is there a restriction on the range? Can it be anything? Can it be -10?
No.
No, it cannot be because there's a minimum. For an even degree polynomial, there's always going to be a restriction on the range. So what is it here? What must it be? What's the minimum y value?
-3.
Yeah, what's the maximum y value?
Infinity.
Yes, so ranges from -3 to infinity. Infinity is never inclusive. It's always exclusive, denoted by the rounded brackets. Can y be exactly -3?
Yes.
Yes, it can be. So if it's inclusive, we use a square bracket for this, okay? If you want the
Mm-hmm.
other notation, you can say y is going to be greater than or equals to -3. Cool?
Uh-huh.
Let's look at the next one. Positive intervals. Positive interval means where the function is above the x-axis, right? Where is it above the x-axis? It's above the x-axis here. How do we denote this part? It's to the left of which x value? Negative
-1.
-2, -2. We're looking at it where it's positive. It's positive right here, right? It's going to
Mm-hmm.
be positive when x is less than -2. What about on this side? See, it's positive here, right?
When it's more than 2.
Yeah, so it's going to be positive when x is less than -2 and when x is more than 2. Cool?
Mm-hmm.
In terms of the set notation, you can say -infinity to -2, it's positive. And then you gotta do, when there's multiple intervals, you gotta do something called union. This just means and. +2 to infinity. Why is 2 and -2 not inclusive here? Why are they exclusive? We're looking at positive intervals. What happens at exactly 2 and -2? What's the y value?
0.
0. Is 0 a positive number?
No.
No. 0 is neither positive nor negative. Okay?
Okay.
It's kind of like water, H2O. What's the charge of water? It's a 0. Why is it 0? It's because oxygen has a charge of -2. Hydrogen has a charge of -1, but there's 2 of them. Sorry, +1, but then there's 2 of them, so this becomes 2. When you add them up, you get a charge of 0, right?
Mm-hmm.
Same idea here. 0 is neither positive nor negative. So that's the positive intervals where the function is above the x-axis. What about the negative interval where the function is below the x-axis? Where's that? It's right here. You see here? Between which two x values is the function below the x-axis?
-2 and 2.
Yes. Are they inclusive or exclusive?
Exclusive.
Right, because negative is independent of 0. So -2 to +2 in this. If you want the other way, you can say it's between -2. X can be anything between -2 and +2 like that. Okay?
Uh-huh.
Increasing. Now this one has both increasing and decreasing. Increasing means where it's going up, okay? And just kind of like draw arrows. We always start from left to right. And you start drawing arrows. Up until this point, you see this middle cutoff point, the function is decreasing. And to the right of this point, again, it's when you say it, it's going to be in terms of x, the function is increasing. So where is it increasing? When x is greater than what?
-1.
Yeah. In terms of the set notation, you can say -1 to infinity. And again, it's going to be exclusive because at exactly -1, the slope is 0, right? The tangent is 0. It's neither increasing nor decreasing. It's neutral. Where is it decreasing? Where's this function decreasing?
When x is greater than -1.
Not greater than,
Less than.
less than. When x is less than -1. Okay, this one I should have said. Oh, actually, no, we're good. We're good. When x is less than -1, or when x is anything between -infinity and -1, like here up until here, the function is decreasing. Okay,
Mm-hmm.
that makes sense.
Yep.
It's not. It's not too complicated. Wait, let me pull up something that we can do. I'm gonna do the graph bits because that's the fun thing, and this will kind of be like a review here as well. Yeah, something like this. And again, it's not that difficult, okay? You just look at the thing, and this is the kind of questions you're gonna get on your test. Well, maybe not in polynomials. Maybe, I don't know, actually. You could. F of x is less than equal to 0, okay? Now, this is not asking you for the negative intervals. This is asking you when is the function exactly 0 or less than 0? Kind of like negative intervals, but now it's going to be inclusive. 0 is going to be inclusive. Um, so it's negative, right? Less than 0 means it's negative. It's negative right here, yeah?
Mm-hmm.
Where else is it negative? That one is when x is less than -5. Where else is this function below the x-axis? There's one right here,
When
right?
x is greater than -2.
It's between something actually because it comes back. When x is between -2 and 0.
0.
Yeah, because it comes back. And here it's gonna be inclusive because they want it to be inclusive. 0 is included, okay? In the
Mm-hmm.
last one, they were strictly asking for positive or negative. This one, they want the zeros as well. Is there any more intervals where the function is negative?
When x is 3 or greater than 3.
Yeah, so when x is greater than or equal to 3, there you go. That's the answer to A. What about B? B is a trick question because there's really no negative. It's never really below the x-axis. but it does have a 0.
When x is 1.
Yeah, that's it. Not even greater than. When x is 1, that's the only time this thing is satisfied, right? Because if you say x is greater than or equal to 1, then you're implying this. That's wrong because it's not below the x-axis. Same thing on the other side. Okay, for C, I want when f of x is greater than 0. Just strictly when f of x is greater than 0 for C. It's over here, that's 1. That's in the middle here, that's 1, and then there's a third one here. Greater than 0 means positive. So what do we got?
When x is less than -7.
That's right, that's one of them. Where else?
When it's between -3 and 0.
Yeah. Yeah, I'm being lazy. I can just do the this notation, or you can say -3x 0. They're both okay. Where's the last one?
When x is greater than 4.
Yeah. So you can say from 4 to infinity, or you can say x is greater than 4. Cool?
Mm-hmm.
Let's do one last one. What about D? Actually, let's spice this up. What can we say? Kind of want to throw you off here. When f of x is greater than equal to 3. Now we're not looking at 0 anymore. We're looking at greater than equal to 3. What do you do in this case? Well, greater than equal to 0 is easy because they give you this black line, the x-axis. Greater than equal to 3 means when the y value is greater than or equal to 3. So what you want to do is you want to make a new line at y equals 3. Yeah? So the function is above 3 right here. That's one interval. And right there, that's a second interval, right?
Mm-hmm.
Again, we don't know the exact values, but we can approximate. So let's say this one here is -3.5. This one is a 1. So what will be the answer to this question?
When x is greater than -3.5.
Yeah, but does it have an upper bound? Because x is greater than -3.5 means x can be 4, right? But we
When
know
it's
it's gonna,
between -3.5 and 1.
yeah, that's one of them. When it's between -3.5 and 1, where else?
When x is greater than 7.5.
Yeah, and you're done. Okay?
Mm-hmm.
What if you don't have the graph? Let's look back into finding how to do the graph to begin with. Let me see if they're asking us to graph this. All right, yeah, there we go. So they'll give you a question like this, okay?
Mm-hmm.
And then they're gonna ask you everything that we just talked about before. Domain, range, they sometimes will ask you. And then they're going to ask you for positive and negative intervals. Then they're going to ask you for increasing and decreasing. Okay. Let's sketch this, and then that's going to give us a better idea. What's the degree of this polynomial? You just count the number of x's that you have.
4.
4. This is a fourth degree polynomial. Positive or negative?
Positive.
Yes. Which quadrant does it start? Which quadrant does it end? Positive 4 is same as positive 2.
It
So
starts in the second.
yeah, it starts in the second. Where does it end?
The first.
Yeah, that's it. Second to first. Where are the zeros of this function? Fourth degree means it can have up until 4 zeros, 4 x-intercepts. One of them is at 1. Okay.
Mm-hmm.
Where are the other ones?
2 and negative 2.
There's one more. It's hiding in the shadows. Like, if you had 1 over x minus 1, the restriction would be 1, right? X can't be 1 because that will give you a 0. What about if it was 1 over x times x minus 1? What are the restrictions? What can x not be? Can't be 1. What else? Is that it? Look at this guy. What can this not be? 0. If that were to be a 0, then you would, doesn't matter what x minus 1 is, you're going to divide by 0 because 0 times anything is a 0. Same idea here. If this guy, you see the x on the outside?
Mm-hmm.
If that guy is a 0, the entire thing doesn't matter what these numbers are. They could be 0, they could be non-zero. If that x on the outside, if that's a 0, the whole thing will be 0. So that means your last x-intercept is at 0. So you have 0, negative 2, positive 1, and positive 2, right? Like that.
Mm-hmm.
And if this is a trick, if the x-intercept is 0, the y-intercept is automatically also 0. Okay? So
Uh-huh.
our function is going to start here somewhere. It's going to go down here, going to come back up here, going to go down here, going to come back up here, and there you go. That's the sketch. Cool?
Uh-huh.
What is a domain of this function?
There isn't any.
Okay, domain means there's always going to be domain. Restrictions, yeah, there aren't any. Domain means the possible x values it can take, right? So the domain, this one, it can be anything from negative infinity to positive infinity. In other words, XCR. X can be anything.
Mm-hmm.
Polynomial, the domain will always be XCR. Doesn't matter what degree the polynomial is, the domain will always be XCR. Now the range is a little bit tricky because do even degree polynomials have a restriction on the range? Or are they going to go indefinitely all the way to infinity on both sides? What do you think? Even degree polynomial, think about x squared. Is it restricted or is it like unbound? It can be anything.
It's restricted.
It's restricted, right? The graph of this guy looks like this. This is the exact graph. If you look at the y value, What would be the range of this function?
It's the y value.
Yeah, greater than or less than?
Less than.
No, greater than. It can be -13, it can be 10, it can be 0, anything but -13. Anything, this number and everything above it, okay? So it's going to
Okay.
be -13, whatever that was, all the way to positive infinity. Cool?
Uh-huh.
Now this one is a little bit tricky. Positive intervals. Again, it's not that tricky. We just did like 5 questions on this. Just look at where the graph is above the x-axis, and that'll be positive.
When x is less than -2.
Yes, that's one of them. Where else?
When x is between 0 and 1.
That's right. Anything else?
When x is greater than 2.
Yeah, there you go. That's where the function is positive. Where is it negative?
When x is between -2 and 0.
Yeah. Anything else?
When it's between 1 and 2.
Yeah. And there you go. Okay.
Mm-hmm.
If you look at increasing, it's increasing from here to here. We don't know where the curves is, but it's increasing right here. Anywhere else? It's increasing from here, like here, this part. See, it's going up.
Mm-hmm.
So that would be the increase. We don't know what the x values there are, but that's the increasing interval. And the decreasing interval is like from here to like this point here, all the way this, it's decreasing. And then again, from like here to here, it's decreasing, you see?
Uh-huh.
So that's how you would graph this function. It's not that bad, right? Is it?
No.
It says, now they've given us an equation and they've straight up asked us to graph this. To graph a polynomial, these are both polynomials of degree 2 or higher, so like quadratic and up. Doesn't apply to linear. Linear is pretty easy to like solve anyways, but anything with degree 2 or higher, you need to bring everything to the same side. Okay? Either you take everything to the right, or you bring everything to the left. Let's look at A. What's the degree of this function?
3.
3, right? What's the domain? Again, it's a polynomial. What's the domain of any polynomial?
-infinity to infinity.
Yes. Now this is an odd degree polynomial. It doesn't have any restrictions on its range either. It's going to look like this. The range, it's going to go all the way down to -infinity, positive infinity. The range for this one would also be from -infinity to positive infinity. Okay.
Mm-hmm.
In terms of positive intervals, I guess we're going to have to first solve this to graph this. Let's solve this. Again, it's a degree 3, so you have to bring everything to the same side. So this becomes 3x cubed minus 27x equals 0. Can we pull anything out right now? You should always pull something out if you can. So GCF.
You can pull out 3x.
Yes. What are you left with? .
3x squared minus 9x.
Close, but no. Try again, you got one more shot. You said 3x squared minus 9x, that's wrong.
Minus 9.
Minus 9 is right. What of the first term? It's not 3x squared.
It's x squared.
It's x squared, exactly. Which form is this guy in? It's in a certain form that will allow us to factor this in order to see the x-intercepts.
Difference of squares.
So what does it factor out to?
X minus 3.
Yes. And then
X plus 3.
3, right? So where's the zeros?
Three and negative 3.
That's right. 3 and negative 3. There's one more though. It's hiding.
0.
Yes. Which quadrant does this start in?
The third.
Right, yeah. And then if the x-intercept is 0, what's the y-intercept?
It's also 0.
It's also 0, right? So it's gonna go this way, and it's gonna come down. Then it's gonna go all the way like that. And there you go. We've graphed this, right?
Mm-hmm.
Can you see why the range is in infinity on both ends? Because there's no upper bound on the y values, right?
Uh-huh.
It's gonna keep going up and up and up, and then on the other side, it's gonna go down and down and down. That makes sense?
Mm-hmm.
So it's only the other thingamajig that has a restriction like even degree. Otherwise, it's all good. Where is this function positive?
When x is between negative 3 and 0.
Yeah. Anywhere else?
When it's greater than 3.
Right. That's where it's positive. What about negative?
When x is less than negative 3. And between 0 and 3.
That's right. And you're done. Okay.
Mm-hmm.
Easy peasy. Same idea with D. It looks pretty menacing, but it's not. We've done a question like this like many, at least 100 times. It's because when you factor something out, it becomes a quadratic. What can we factor out? Can GCF out something right now?
2x.
Yeah. What are we left with? There's going to be three things.
5x squared.
That's right.
Plus 13x.
That's right.
Minus 6.
Yeah, that sounds about right. Which form is this in? This is our good old friend, man. Quadratic trinomial. You see it?
Mm-hmm.
What does it multiply to? Be careful.
Negative 120.
No. Yes, but no, you gotta look at this bit here. That's why we take out the 2. Because negative 120 is such a nice number. It has so many factors. You don't want to deal with 120.
Negative 30.
Yeah, negative 30 is easier to deal with because there's only 2 things. Well, there's more than 2, but 120, there's like 7, 8 things. It adds up to 13. What are the numbers?
Negative 3 and 10.
Negative 3 and positive 10?
Mm-hmm.
Or negative 3 and hmm. But then that doesn't add up to 13.
Oh,
Yeah, it's not negative 3 and 10. There's something else. Think. It's not 6 and 5. There's only 3 things that multiply to 30. 3, 10, 6, 5, and there's one more.
$15 and 2.
Yeah, which one's positive, which one's negative?
2 is negative.
2 is indeed negative, so 15 and negative 2, right?
Mm-hmm.
So with this, what you do is you always are going to break the middle guy down. So 2x, 5x squared plus 15x minus 2x minus 6 equals 0. From the first 2, we can pull out a 5x. We're left with x plus 3. What can we pull out from the next 2?
Negative 2.
Yep, and you're left with x plus 3 as well. So your answer is going to be 2x times 5x minus 2 times x plus 3. Okay?
Mm-hmm.
All right. What are our zeros? Now be careful here.
Negative 3.
Negative 3 is one of them, yeah. Any more?
2/5.
Yeah, good. 2 over 5, which is like 0.4. Is there any more?
0.
0, exactly. So this one also has 3. And if the x-intercept is 0, the y-intercept is what?
Also 0.
Yeah, automatically 0. So we have another cubic function that looks like this. What's the domain and what's the range of this cubic function?
They're both negative infinity to positive infinity.
Right, there's no restrictions on domain and range. It's negative over here to the left of negative 3 and between 0 and 2 over 5. It's positive between negative 3 and 0 and to the right of 2 over 5, right?
Mm-hmm.
And you're done. But what if I told you we can go a level deeper? We can find out, okay, here's a 10-point question. This will be, yeah, this is, right now with this graph, we can do everything that we did, but if they ask you this one, increasing and decreasing interval, right? If they ask you this, then we're kind of toast because right now we don't know where this is. To find the increasing interval, you need to find out where the thing bends, yeah? It could be like that, or it could be like this, could be like that. There's multiple possibilities. So this is the end game. We need to find where this guy bends and where this guy bends. Okay? What's so special about this area and this area? What's going on there? there's a turning point, right? It flips. What's special about a
Slope to
turning point?
0.
What's 0?
The slope.
The slope is 0, right? Now this is f of x. We need to find f prime of x, the derivative. Now if you remember the rule, if you have axn, the y prime, the derivative, first bring the n down. Okay, first bring the n down, and then you take 1 away from it. For example, y equals 3x5. The derivative would be 5 times 3. 5 comes down. 5 times 3, x to the 4. Okay?
Mm-hmm.
So let's do that here. What's going to be y prime?
30x squared
Yeah. What about the second term?
plus 52x
Yeah. What about the last term?
minus 12.
Minus 12. This is your slope function, right? What's the slope at our turning points? It's a 0, like that. So we're going to solve this equation. Again, it's a quadratic trinomial. They're all divisible by 2, so let me pull that out to make life easier. Cool, like that. All right, now is when we hit a little bit of a roadblock, because that's a quadratic trinomial, multiplies to negative 90 and adds up to 26. The numbers probably don't exist, okay? I can't think of anything. 15, 6, yeah, no. It probably doesn't exist. 18, 5, yeah. How do we find the x-intercepts of a quadratic, okay, when we can't factor it? Do you remember? Yeah, let's first see if this one even has x-intercepts, and it does. How do I know it has x-intercepts? Is this opening up or down? Look at this guy.
Up.
It's opening up. What's the y-intercept?
-6.
-6. The y-intercept is down here, and it's opening up. So that means, you see, it has to cross the x-axis. So it definitely has x-intercepts. But we can't factor this. So what do we do? Well, for a quadratic, this only applies to quadratic. Things that you can't factor, you're going to use the quadratic formula. And we have done this in the past, but it's okay. Here's how you do this. Your quadratic is going to be in this form, ax squared plus bx plus c, okay? Quadratic formula says your two x-intercepts are going to be negative b plus minus, again, this looks weird, minus 4ac all over 2a. It just looks menacing. It's pretty easy to use, actually. Compare this with this. What's a, b, and c? What is a, b, and c?
A is 15,
Okay, what's b?
26, and C is -6.
Right, so step one, you always want to identify what a, b, and c is, okay? A
Mm-hmm.
is 15, b is 26, c is -6. What do you do next? You're going to plug it into this formula, okay?
Mm-hmm.
Negative b, so negative 26 plus minus 26 squared minus 4 times a is 15 times c is -6 divided by 2 times 15. You understand so far what happened? We're
Mm-hmm.
plugging things into this guy. And what you do is, I'm just going to plug the square root bit. Pull this out. Square root of 26 squared minus 4 times 15 times -6. So I get negative 26 plus minus 32.19 over 2 times 50 is a 30. Like that. What this means is this is going to give us two different x-intercepts. The plus bit, when you have a plus minus, what you do is the plus bit becomes its own term, so like this. And then the minus bit becomes its own term, like this. You see that?
Mm-hmm.
Plus minus. This will give you one of the x-intercepts. This will give you the other x-intercept. So negative 26 plus 32.19 divided by 30. That gives me 0.2. For the other one, negative 26 minus 32.19 divided by 30. That gives me negative 1.94. So if you look at the graph, you see this point, x, is this x 0.2 or negative 1.94?
Negative 1.94.
Exactly, negative. So there's our first turning point, negative 1.94. That means our second turning point is at 0.2. Okay.
Mm-hmm.
Now using all this, you need to do all this to basically find where the turning point is to graph it precisely. Now we can answer this question. The question was, what is the increasing and decreasing interval? Now look at this. Again, start from left to right. Draw arrows. It's increasing here, yeah?
Mm-hmm.
And then it decreases here. And then it increases again. So what's the answer? Where is it increasing? It's increasing to the left of negative 1.94, you see here?
Uh-huh.
So how do you say that? Well, you can say it's when x is less than negative 9.14, 1.94, it's increasing, yeah?
Mm-hmm.
What about here? How do you denote this? We know that point is 0.2.
When x is greater than 0.2.
Yeah, when x is greater than 0.2. Where is it decreasing?
When x is between negative 1.94 and 0.2.
Exactly. And there you go. You need to do, this is going to be like a 10-point question because there's a lot to this. Okay, increasing and decreasing interval, probably the trickiest. And this one wasn't even super bad because we found the derivative and it ended up being a quadratic, and we know how to deal with quadratics. But sometimes when you find the derivative and it ends up being power 4, power 5, then there's going to be additional steps. You're going to have to factor that using synthetic division, and then eventually you're going to run into a polynomial, but there's going to be one or two extra steps. Okay?
Okay.
Here, let's look at this. Again, this should be pretty clear now. This is a cubic polynomial, starts in Q3, ends in Q1, infinity to negative infinity for both domain and range. The question is factor this. How do we do this? Can we pull anything out right now?
No.
Yes, you can. Think. If you can pull something out, always pull something out. Right now you can pull
Oh, a
out a
2?
2, right? Yeah. If you pull out a 2, what are you going to be left with?
X cubed plus 81.
Yeah. So you can divide both sides by a 2. That 2 is gone, right? How do you factor x cubed plus 81?
Difference of squares.
Difference of squares? Nope. Is that a square? It's not a power 3. It's not a square, and it's not a difference either because there's a plus sign in the middle. It's a sum of cubes. Okay? Sum of cubes. Now, what is this? We've done this in the past as well. It looks like this. If you have a cubed plus b cubed in this form, yeah?
Mm-hmm.
Is this in this form? It's not, but you can kind of make it because 81 is simply 3 cubed. You see it's in this form, a cubed plus b cubed form. To factor this, this is going to become a plus b, okay? a squared minus ab plus b squared. This is a formula for a sum of cubes. There's also one for differences cubes. The only difference is that this sign is going to become minus. So using this formula, okay, can you tell me what does this factor out to?
Um,
Let's go one by one. Yeah. What is a here? Basically comparing, and we're just comparing this, right? Like comparing, like every formula that we use, we're basically comparing things. You see, what's a? A is x. So it's gonna be a plus b. So x plus what's b?
3.
3, right? The next thing is a squared. So what is that?
X squared.
X squared. The next thing is minus ab. So minus what?
A times 3.
3 times
And then
x.
x times 3.
Yeah, so that's 3x. What's the last term?
3 squared.
Yeah, plus 9. Okay, and this is going to be equal to 0, you see? Now one of our x-intercepts is minus 3. And now for the other one, two numbers that multiplied with 9 and add up to negative 3, do they exist? Multiplied with 9 and add to negative 3. No, they don't, right? The only thing that multiplies to 9 is 1 and 9 and 3 and 3. No combination of this will ever add up to negative 3, yeah? There's only one x-intercept. Y-intercept is given in the question, 162. X-intercept is negative 3, starts in Q3, ends in Q1. So it probably looks something like this. And we'll end it there for today as well.
All right,
But
thank
by
you.
the way, yeah, as of right now, there's no class for tomorrow. Okay? As of right
Okay.
now. If something changes, your mom will let you know.